got mode append. By using this, what happens in steps? So what are the steps here? Steps means this one. What are steps? Hour equal to 2, hour equal to each hour. So each hour data I am taking and I am appending. Like that I am creating 24 files. So I am running the command. See, I created these files, CRC files. Okay, each for each hour. Streaming data. Okay, so this is what the streaming data I created from a single data. So now what I'm doing is, see here, I'm just displaying those files in the same content, our folder, our record, which all the files are there, I'm displaying the files. Now see, checking any one file from below, I'm taking one file and I'm displaying the data. Okay, so this is the file I have taken .csv file and I am displaying the data. So what is the data? This is 14th hour, complete 14th hour data I have taken. So now what happens is, see, now see here, if I run you will get an idea. This is an explanation. Now if you see, I am running this part.schema. Okay, so each type, what is date type, temperature type, structure field type, okay, all these things, just describing the data. Now the actual streaming, okay, type streaming data frame. Now see, this is done right. So I will explain, no need to worry. The aim is, see here, I started the query, see, temperature 1, 2, it's completely streaming. Okay, so whenever I receive the temperature and humidity, I will average until I get. Okay, see, it will keep on running whenever I get any data. So continuously, as and when I receive the data, I keep on processing. So we will wait. Once I get, we will take the average of temperature and average of humidity. See, 12th hour we got one data, 20.3, 60.8 random. Keep on running. So whenever we get a data, okay, we need to compute this. See, whenever data comes, I need to compute the average and average of temperature, average of humidity. So it will keep on running. So let's see. Next, I got one more data. Next, the average. 22 hour is over, 12 hour is over. Okay. So what is the average? Okay, next it will keep on running. If I don't get any data, I am adding S and L. If I get any data, it will take that hour and it will compute the average. See, 1 hour, first hour came. So like that, it will keep on streaming, it will keep on running. As and when I get the data, it will compute the average of temperature and pressure. See here. Now I got 13th hour data. Okay, so this is how we can use Spark for streaming live data. So it's keep on coming. We can see now 6 come. When 6 come, what is the average temperature? Now after that I will explain the logic. Continuously it will keep on running. So it will keep on running and it will check whenever it receives the data, then it will compute the average temperature and average humidity.
Streaming should it be always like first hour, second hour, third hour?
Yes.
In order.
Streaming means order only, time series.
But when they are getting the display, it's only 22 hours.
No, that is fine. Here you see. Here we call this as hour 0. See, you don't look it here. This is hour 0, hour 1. This is the order. Some order is there. Okay, based upon this, we are retrieving the data. So as and when new data comes, see, if there is a new data, it is null. When you get new data, what is the average? So it will keep on running, see, it will keep on looking for the data. Okay. time steps. How many time steps we are looking into? So we can keep it as 1,000 or we can keep it as 100. Okay. So see here. So 45. Okay. So keep on running and we are getting data from this. It will keep on running. See 4, 5, 6, 7, 8, 38. Almost we got the data 40, 41, 42. Okay. 43. 44, 43, 44, we got this is the data. This is the data we have. So we can increase. Say we can make it 100. Because it is appending. I didn't change this, so it is keep on appending and it will try to get the data.
So there should be a condition that if it is more than 50, then we display.
Depending upon which is important to you. If you keep on displaying your log files, maybe so maybe every 100 you compute the summary and then you display the data. Here also we are not displaying the each individual. We are displaying the average.
Screening, you make it as values to it.
You have to process. You have to write the logic here. See, this is where here when you go see here. So when you get the values, okay, select start from here. You have to write the processing logic.
Check for all the possibilities.
Everything depends on criticality of application.
Suppose release cap, delete cap.
If the image is blur, completely blur, there is no information. All pixels are not having higher intensity values. You don't want to store that image. I want to process that image.
File you would convert to CSV.
This is CSV file.
Image file.
No, image, we have keep image format, only store it into folders. Here you can display. Here I am taking average, there you can take any, selecting one image out of 25, something you can do process.
Image you can make the pieces and
If the image is improved version of the previously received image, you can take that image possible for as a representative for maybe same other class and extract the features. Rather than extracting features for all the images for the class, take the best mean and you can extract. So like this you can play. So you can check any active streams are there. Streaming query. Waiting for data to arrive. Okay. And finally you can stop the streaming. So what actually you are doing here? So this is the logic. So first what you did. So first you have to create the session and you have to take the data set and what we did is we checked which are all the columns and we just checked the first two rows. Then what we did is we selected the data types of date. So data types of date are two types. One is this format, another one is the see this format. So here the date and string format. So here we have the data type. Date is of type combination of date, comma, string. Next, what we are doing, we are grouping by our column and we are counting. Okay, so we are counting and we are displaying only the 24 hours, 24 values only. So these are the values. Next, what we did, we created one folder. So where is that folder? Here is the folder, our folder. Then what we did, we select how many steps are there. So select our dot distinct dot collect. So our column distinct values. So those are 24 only. So those are steps here. So we printed the steps. What are those? 12, 22, 1, 13, etc. These are the various our values in the order in the data set. So what is the type of steps? It is a list. And how many values see here? What is the first value? 12. So those are the hours which we computed from the this one, hour 12, 1. Okay. So like that we computed various values. Okay. Next what we did is, see here. So we taken 0, 0 steps 0, 0. So what is steps 0, 0? Steps 0, 0. That means hour equal to 12. So when hour equal to 12, what is the data? So hour, these are the minutes. Okay. So when hour equal to 12, this is the data we have. Next, what we did, we want to create a streaming environment. So for each hour, we split the data. For that, we used a function called collapse. So what we did here, so see df dot where each for step dot 0. So here we have total steps, hours. See here, steps equal to hours. In that, what we did for each hour, so for step 0, see here, df1 dot collapse1 dot write into this record. So we have content, our folder, hourly record, our folder, hourly record. So in that, these are the values. Okay. Now see. Okay. So we keep on appending the values. Next, what we did, see here, we just displayed one value. If it is CSV, so these are the CSV files we have. If you count how many are there, how many values? 24. Each for the 1 hour. Okay. Next, you can download and check also CSV files, not the CRC CSV files. So each CSV file is for 1 hour. You just split it. See here, CSV file for 1 hour, we split the data. This is the streaming data for every hour, every week. Okay, like that you go to you take any CSV file, it represents 1 hour. Then what we did, that is how we able to do it with the help of a collapse. Okay. Next what we did, see here, hourly record list. Okay, so checking any one file from the above. So we are hourly record list. So where is hourly record list? This one. From this list, these are the list values. Randomly we have taken one value from the length and random value we just displayed the data. Okay, this file name I appended here and then we got the data. Now what we are doing is the programming mode of structured streaming. So what it will do, please read this, how the streaming will happen. A sheet stream means as an unbounded, continuously appended table as illustrated in figure. So we can keep on appending the value. So where we are doing that, here we are doing. When we are running, we can keep on appending. This is one summary of the data. Next, another summary, another summary. So how we are computing the streaming with the help of a table. Okay. Now please read this. Okay, So please read. Every new record received in the data stream is like a new row being appended to the unbounded input table. This is the table, it is unbounded table. Whenever there is a new record, we keep on appending the data. See here. So trigger first one. First second, we have only one data. Next, what happens? See, we will append the data 1 and 2. Next, 1, 2, 3. As time goes on, we will keep on appending the data. Okay, so see here, spark dot, read stream dot, schema, auction dot, max files per trigger dot, CSV. This CSV which we are using to convert into a streaming data. Okay, so hours folder, hourly record. So if you go here, hours folder, hourly record, here which is the extension we are using? What is the extension? .csv. So .csv files we are using. And what is the max files per trigger? 24. See, maximum number of files to be considered in every trigger. So here you can take one file at a time. Trigger it, one file, take the value, average it, append it. Take the file, average it, append it, and display. That's it. Okay. So what we are doing? What actually we are computing? Average. Average of what? Per group by hour. Then mean of temperature, mean of humidity. So humidity will average and temperature average we are computing. And we are ordered by displaying this decreasing order of hour. So this is what we are appending it to the table. See here. See. Then this hourly mean value we are writing it to the stream, query name, temperature, humidity mean, format and memory, and output mode complete dot star. So this here we are writing, and this is the writer. What actually we are writing into that particular table is temperature, humidity mean. Okay, in only format. These are syntax. Output mode complete. Okay. So now it will start the query. So when we run the query, what is the query? See here, search stop from temp humidity mean. Okay, and then it will keep on. What is this temp humidity mean? Is what is temp humidity mean? Temp humidity mean. Mean of group by mean of temperature and humidity ordered by this one. This is hourly mean value, and see here. Here we specified. Okay. So temp humidity mean. So where is the temp humidity mean value? This one. We are writing the stream into this. From here, when we are writing, here we are selecting. Same syntax. This is no logic here. Okay. So I will explain again. So first we have a single data set. First we install the PySpark, and then we imported the necessary functions. Next, we created the session. We taken the master data set, and then what we did is master data set. We check the number of hours. Now here we are creating the streaming version. To create the streaming version, we use a function called coalesce. What coalesce will do is it will split the contents from the master data set into sub data sets as a CSV file. How to split that? Using the hour column. Okay, see here. By using hour, we are splitting. Then what we are doing? We are appending all this into the data set in the folder. This is the folder we appended. Okay. Next, we check one of the file. Now what we are doing? We need to create one unbounded table. The unbounded table means as and when a new entry comes, we keep on writing into the table. When new hour 0 comes, that data hour 1, hour 2, hour 3. Here we have only 24. In real-time applications, there will be 20,000. There will be 1 lakh appends we have to do insertions. Okay, so this is the unbounded table. Whenever there is a data stream comes, what we are doing is we are performing an operation and we keep on inserting. These are the various columns. Okay. So now see, as time goes on, whenever we get an input, we are executing the query, we are getting the output. Same here. Next, time equal to 2. So here what happens, as time increases, we are getting data increases. Time equal to 1 first query, 2 queries, 3 queries, etc. See here. So what we are doing is we are creating this streaming object and options how many at any point of time, how many files I need to consider. Okay, we may consider 2 files, 3 files, etc. So because we are dealing for hour wise, I am taking only one CSV file. And then what I am doing, from where I am taking that hourly record. You need to specify which is the source of the data set and how many files from that I need to consider. Okay, that is called as streaming object. Once a streaming object is created, you need to compute C here. By using the streaming in that streaming object, you are applying group by for every hour, and you have to compute mean value and the cumulative value. That's what this hourly mean value. Okay, this hourly mean value is a data point. Then what you are doing, see here, hourly mean value, that hourly mean value you are writing it to the writer. Okay, and then that writer, okay, what is the query name? Temp QME. What is this query? This is the query. You always keep on selecting and you keep on displaying the data. Okay, so because it's already been ran, so if I remove that, okay, so I am restarting everything. Okay, so now it will again generate all the process one by one. See, this is the unbounded table. This is the unbounded table. What we discussed here. This is the unbounded table. Whenever new data comes, we keep on running. Okay. So it is running. See, it is keep on running. There is no data. Whenever we get a data, we keep on appending the data. So per hour came, we appended the data. Next, in decreasing order, we sorted by decreasing order. So next came 22. So here for hour 1, what is the average? 15.66. For 6, 15.17. Okay, for 6, 15.17. Okay, so same is displayed here. 15.17. For 22, 16.21. For 22 hour, what is the temperature? 22 here. How much? 16.19. Okay, 16.21. Sorry, I missed this one. Okay, till here 22. 16.21. Okay, it is computing the average temperature and average pressure, and it is displaying in the decreasing order. So as and when it gets new record, it will keep on computing the value and appending to the table. Okay, so this table is what they explained here. This table. So unbounded table, new values are keep on inserting into the table. Okay. So here, what are the query? What we need to append? You need to group by the hour, compute the mean of temperature and humidity. That's what you need to compute, and you have to append in a decreasing order of the hour. That's why the hours are getting decreasing order. Okay. So you have to specify from which folder I need to take the data and which format, and how many files you need to consider at a time. So it's keep on appending the data. As and when new data comes, it will keep on computing the average of temperature and average of the humidity. Those are syntax. Okay. Almost everything, all the hours that is reached. So we got the calculated. So if for your, suppose you have real-time streaming data, which part of the code we can remove and from where we need to start? See, here we create a virtual streaming environment and we started generating the data and we are accumulating the results. Suppose if you have a real-time streaming data, from where we need to start the code?
Just receive a particular thing.
Where? Which part? Where we need to start? I will start from beginning. You tell me to stop there. I will stop. Where I need to stop?
Yeah, no need to produce the data.
So, part of the schema, create schema, this is same, and here you have to specify your own folder where you kept your data. Okay, and how many files at a time you want to consider. Because we need automatic data 1 hour at a time, we mentioned it one. If you put two, it will take two at a time. That's it. And then which are the columns you need to compute. In our case, temperature, humidity. In your case, it may be average groceries or average house rate, whatever it may be. And then whichever on which column you want to group it. That's it. Okay. Next, you have to specify which query name and format is in memory. This is same. Just you have to specify the query name, temperature, we see here. And then you have to specify from where you want to select the data. That's it. It will keep on automatically. Simple. Once you are streaming data, you can get the data and you keep on computing. Whenever a new transaction happens, whenever there is a data entry into that column, that folder here, okay, it will keep on take each data. It will take CSV file. You have to put it in this folder. That's it. When new data comes, it will keep on computing.
These will be the recorded data which has to be uploaded in the folder and then.
Yes, you have to link it to your folder. So anything you have to put it for. Once you get the result of a BCG or a COVID result, you have from the actual result, you have to put it in a folder. From there, it will keep on sensing it. It will get it. Real time means it cannot. No, real time means if you put it to data folder, from there it will take the data, the reports, and then it will compute the values. While storing itself, you have to dot save. When you compute the values, when you get the report, you add dot save. It will save into this folder. Whenever there is a save into this folder, automatically streaming will get the data. That's it. You got it again? See, whenever you return some logic, at the end you will add dot save to that folder. All your reports will be saved into that folder. Whenever there is entry into that folder, automatically streaming will get the data. See, it has to look into one folder where the model code has to look into. So you have to link it to one folder and one query. That's it. If you place that folder, automatically it will take the data. So once you get the image, you put it in that folder. That's it. Real time doesn't mean that immediate. Whenever it comes, you put it into that folder. Okay, see, in MATLAB, what we will do, suppose after processing the data, you add one logic. What is that? Dot save. In Python also, when you process anything, you can add dot save. Dot save of location. That location is this folder where you link it, this one. This is what the folder. This is the folder. Here you add as a dot save. See, by getting the data itself, you add dot CSV to this file. So when you done the work, you are putting into folder. From folder, automatically you are running the streaming logic. So it will keep on looking into the streaming data. Whenever there is entry, it will compute the average, or depending upon your logic. For demo purpose, we just taken a simple CSV data. You can keep step by step, you can increase it. Okay, so this was the various ETL operations you can perform. Outliers, finding the outliers, same logic. Okay, outliers, you can compute the describe, overall mean, average, percentile, etc. Complex C. Here you need to work on assemblers. Streaming because vector assemblers you need to focus and you need to compute the new columns. Okay, so lots of logic are there, but at a time I don't want to push everything into your brain so slowly. So this is various ETL columns you can work on, and this is the streaming data you can create and you can get the data. Okay. So any doubts? Okay. If you are done, then I am also. Can anyone summarize how to create a streaming process? What are the steps involved in the streaming process? Syntax, you don't worry. Syntax will be there. You will not need to worry about syntax. What are the steps we need to create? Summarize the steps. No need to see the books, just what you learned, what you understood, that's it.
Download the data set, written reports, then access the column, check the data types of columns and of names, then check for any null values or not a number value. Clean it, pick up the null values. Then you will write it as then if it is not time series, and make it time series.
Streaming. What is the function we are using for splitting? Huh? Coalesce will take the data column wise. So here we split our column. So based upon our unit, our value, we will take the data put into CSV file. Now we are calling it as streaming data per hour, and then we need to link it to folder, and we need to link it to query. That's it. When you run the streaming object, it will keep on looking into the folder. Whenever new data comes, it will take the data or executes the query. Okay. So here, once you've done every logic, okay, here you can write the logic to save into this folder. Here, once you get the data, save off into this folder. So what happens when you run this? Automatically, at the end, it will go to the folder. From that folder, you are running the streaming learning. So it will take the data from automatically, it will consider the streaming data. Okay. So what is the important step here is this one. Once we collapse, we need to create the unbounded table. Okay. So unbounded table. So you need to streaming. You need to perform the streaming operation. First streaming step is which folder you need to look on, and what is the file you need to look on, type of the file, and how many files you need to trigger. Okay, see support the file CSV. Then what